Hi students, this section is graphing linear inequalities with two variables. So one thing you're going to see in this section is they're going to give you like a standard form inequality. For example, here you have that 4x plus 5y is less than or equal to 12. And they're going to give you ordered pairs. For example, A here you have -3, 5. They want you to substitute that -3, 5 into the inequality to see if it's true or not. So -3 is representing my x, 5 is representing my y. So I am going to substitute that in. So we have 4 times -3 plus 5 times 5, and is that less than or equal to 12? 4 times -3, -12, plus 25, is that less than or equal to 12? So -12 plus 25, that's going to give me 13. Is that less than or equal to 12? No, that is not true. So we are going to say my answer here, no. -3, 5 is not a solution. Let's look at B here. We have 0, 2. Again, we're going to substitute 0 in for x, 2 in for y to see if it's true with the same inequality of 4x plus 5y is less than or equal to 12. So 4 times 0 plus 5 times 2, is that less than or equal to 12? So we have 0 plus 10. Is that less than or equal to 12? Yes, it is. 10 is less than or equal to 12. So we are going to say yes, 0, 2 is a solution. And you're going to see how this is going to help us out later on when we get into these notes when we go about graphing this. All right, so I need you to write this down. Graphing linear inequalities. So we looked at some solutions with inequalities in the previous slide. For this one, it's going to now get into graphing. So the graph of a linear inequality in two variables is the graph of the solutions of the inequality. So what that means is the graph of 2x minus 3y is greater than or equal to -2 is shown here off to the right. Every point in the shaded region and on the line is a solution of the inequality. Every other point on the plane is not a solution. So what we've done here is we have put this inequality in the y equals mx plus b form, of course using the correct inequality sign. And then they've shaded where the inequality is true based on points you pick within the shaded region. So like for instance, if I put that 2, -1, which is in the shaded region of this inequality, it's going to make it true, a solution of the inequality. So let's go ahead and solve this inequality where we're going to put in 2, -1 into the inequality to see that it's true. So we have here 2 times x, 2 is my x, -1 is my y. So 2 times 2 minus 3 times -1, is that greater than or equal to -2? 2 times 2 is 4 plus 3. 4 plus 3. Is that greater than or equal to -2? So we have 7 is greater than or equal to -2. Is that true? Yes, that is true. So that's why our graph is shaded in that region right there. So then if we picked a point above the shaded region, for instance here if we had the point 0, 3, and we plug that point into the inequality, you will notice that this ordered pair is not a solution, which makes sense because it's not shaded in that area right there. So if we have 2 times 0 minus 3 times 3, is that greater than or equal to -2? 0 minus 9, is that greater than or equal to -2? No, -9 is not greater than or equal to -2, so that's not a solution. Note that inequalities are going to be shown and written in the standard form of ax plus by equals c, and you are going to need to put that inequality into the slope-intercept form, y equals mx plus b, in order to graph, of course, using the correct inequality symbol. So we're going to go ahead and practice graphing inequalities, shading, and then picking points that will make the solution true or not, and shading within that region. So the steps to do this, we are first going to graph the corresponding equation, which means you're going to put the inequality into the slope-intercept form. This is very important. You are going to be using a dashed line for inequalities with the greater than or less than symbol. And you are going to be using a solid line for the inequalities with the greater than or equal to or less than or equal to symbol. Once you're done graphing, you are going to test a point in one of the planes to find whether it is a solution of the inequality. And then step 3, if the test point is a solution, you are going to shade in that plane, that area of the graph. If it's not a solution, then you're going to shade in the opposite plane based on what we graphed there. So let's go ahead and graph this. Our first example here, getting into the graphing, they want us to sketch the graph of y is greater than -3. So think of it in the terms of y equals 3, but we're really working with the inequality of y is greater than -3. Oops, -3. So again, x going left and right, y up and down. So we're going to find the point on the y-axis. Y is -3. Here it is. Now looking at the inequality, it's greater than. So since it's just greater than, we're going to be creating a dashed line. And then y is greater than -3. So y is any number greater than -3. So is -2 greater than -3? Yes, that is true. Is 0 greater than -3? Yes, that is true. So we are going to be shading everything above -3. And this graph represents y is greater than -3. If we said -6, is that greater than -3? That would be false. So that's not a true solution. That means that would be the numbers below -3 here. So that's why it's not shaded. Since this is a false situation, we're not going to be shading in that region right there. Example number 3, we are going to sketch a graph of y is less than 1. Notice the inequality symbol here is a little bit different. It's less than or equal to, so it's including that number. So this is going to be a solid line. So we're going to go to the graph here. We are going to find the point 1 on our graph, which is right here. And we are going to be drawing a solid line since y is less than or equal to. So it can include the number 1 or any number less than the number 1. So I'm going to draw the best straight line I can possible here for you. And y is less than 1. So it's going to be everything shaded below the number 1 because 0 is less than or equal to 1. -1 is less than or equal to 1. So those would all be true situations. So that's how I go about shading that. Example number 4, here we have sketch the graph of x minus y is less than 2. So our first step here, let's put this in the y equals mx plus b form using the correct inequality. So if I have here x minus y is less than 2, I first need to subtract x to both sides. So I have negative y is less than negative x plus 2. I'm putting that in the mx plus b form. Notice we have a negative y that needs to become positive. So I'm going to divide each situation by negative 1 here. So, and we're dividing by negative, so we have to flip that inequality. So it's going to be y is greater than negative 1x divided by negative 1 is going to give me a positive x. 2 divided by negative 1 is going to give me a negative 2. So this is my inequality that I'm going to graph off here to the right. So my starting point here is at negative 2. So I'm going to find negative 2 on my graph and put my point there. And my slope is 1. So this is my slope. So I'm going to rise 1, run 1, and put my points. Now this is saying y is greater than x minus 2. So this is going to be a dashed line because of the inequality symbol. And we need to pick an ordered pair now that makes this true. So y is greater than x minus 2. So let's pick the point 2, 1. Let's pick this point here. Okay, so I'm going to use the point 2, 1, and I'm going to put it into this inequality to see if it's true. And if it is true, then that's the area in which I'm going to shade. So 2 is x, 1 is y. So 1, is that greater than 2 minus 2? 1 greater than 0? Yes. 1 is greater than 0. That is true. So since that ordered pair is true, we're going to be shading above our line here. And that graph with the shaded region is what represents the inequality here. All right, our last example here, we have sketch the following inequality of 3x minus y is greater than or equal to 5. So actually I'm going to pause here and I'm going to start a new video to do this last example because I'm running out of time in my screencast.